Here are our solutions for perfect problem 2 for Math 243. So what's going on here? I'm curious if the amount of sleep I get in a given night affects the number of cups of coffee I drink the following day. That's key, because what you'll see in question 1 here is they ask me what's the explanatory variable, what's the response variable. Explanatory variable is the cause, response variable is the effect. So when you read this sentence, it says, I'm curious if this causes this effect. So the hours of sleep would be the cause, aka the explanatory. And then the cups of coffee I drink the next day would be the response. So that's important. These are my x's, these are my y's. So analyze all this data. Okay, part 1, just determine which variable is which. I already did that. Part 2 says find the least squared regression line and explain the meaning of the coefficients. So, okay, part 2 down here. What you want to do is first put your data into lists. I went ahead and did that already. It looks like my x variables are in L2 and my y variables are in L1. That'll be important. And then what I want to do is I want to go to Stat and Calc and do linear regression. Then I tell it where my explanatory variable is, so I put it into L2. And then comma where my response variable is, so I'll say L1. And you can't just hit enter at this point, but what I'm going to do is I'm going to go one step further and I'm going to save my linear regression equation into y equals. So what I'm going to do is I'm going to put another comma in and then hit variables and go over to y variables, then function, then y1. So what this is saying is do your linear regression, here's your x variable, here's your y, and save it in y1. So if I hit enter here, it'll give me my linear equation. It'll say y hat is equal to ax, a being negative 1.5 maybe, negative 1.5x plus b, which I don't know, 14.6, something like that. But it also wants us to analyze these to determine what they mean. So this value of a right here, this negative 1.5, means that for every increase in 1 in the explanatory variable, my response variable will go down by 1.5. That is, for every extra hour of sleep, I drink 1.5 less, because it's negative, cups of coffee the next day. And this 14.6 right here is saying if I slept 0 hours, I'd expect to drink a lot of coffee, to drink, 14.6 cups. Okay. Part 2. Sketch a scatter plot. Include the least squared regression line. Alright, I can do that. So I guess this is actually part 3. I want to make a scatter plot. My x variable is the hours of sleep, which goes up to 12, it looks like. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's hours of sleep. And then cups of coffee, looks like that goes up to 20. 5, 10, 15, 20. Cups of coffee. Alright, and then I can plot all these points. You can either just do it using the observations, or you can have your calculator do it and kind of copy your calculator. That sounds easier, so maybe I'll do that. So I'm going to go up into Scatterplot, so second, and then y equals. And then under my first plot here, I'll turn it on and select Scatterplots, first type here. And remember my x variables I put in L2, and my y variables I put in L1. Mark it with whatever the hell you want. Zoom stat, which is the 9th thing on the list, to view your scatterplot. I get something that looks like this. Alright. I can kind of trace it so where's my trace button up here to see all my observations. I got when x equals 10, y equals 0. So I got a dot right here. And then I got when x equals 8, y equals 1. So there's 8 and approximately 1. X equals 2, y equals 11. And then x equals 7, y equals 2, 5, 6, 7. I don't know, 1, 2, somewhere in there. X equals 8, y equals 2, 5, 6, 7, 8, 2. X equals 3, y equals 9. 1, 2, 3, 9. 0, 20. Way the hell up here. Stop. 0, 20. 5 and 5. 12 and 1. 4 and 7. I don't have that one yet. So somewhere in there. And that's my last observation. And then I can draw my least squared regression line. It's supposed to go at 14.6. Maybe I'll do that in a different color. 14.6, so near 15. And then down 1.5 every time it goes over 1. So it should cross, well, follow this picture here. It'll look something like that-ish. So there's my least squared regression line. I guess that's everything I wanted from part 3, right? Part 3, scatterplot, include your least squared regression line. Determine R, interpret its meaning. I think we had that earlier. Calc, linear regression. Oh, there we go. It's still up there from earlier. My value of R, so here's 4. R was equal to negative 0.903, which means I have a fairly strong because the absolute value of this number is near 1. Fairly strong negative correlation. Negative because this is a negative number. So determine R, interpret its meaning, done. Yesterday was the last observation. Yesterday my value of x was 4 and my value of y was 7. That's what it's saying. So x was 4, y was 7. So it wants me to calculate the residual. To figure out the residual, I have to know y hat. So y hat is negative 1.5 times your x value, 4, plus 14.6, which is approximately negative 6, and 14 is 8.6. So my value of y hat is about 8.6. So my residual, which is y minus y hat, is 7 minus 8.6, which is negative 1.6. So if my residual is negative, that means I drank 1.6 less cups of coffee. It's supposed to be so. So I drank 1.6 less cups of coffee than expected. Yeah, so when x was 4, 1, 2, 3, 4, and y was 7, it was this observation here. And note this is a little bit below our least squared regression line. It's supposed to be 1.6 below. All right, a couple more. 6 says calculate r squared, the coefficient of determination. Okay, r squared is equal to 0.815 over here. And so what that means is that 81.5% of the variance in cups of coffee drank is due to variance in sleep. In other words, there's a lot of things that determine how many cups of coffee I drink, but one of the things is how much I slept the night before. That's a pretty big factor, 81.5% of how much variance I have in cups of coffee. There's a lot of variance. Look at cups of coffee. One day I drink 0, one day I drink 20. A lot of variance going on there, but 81.5% of it is due to how much I slept. And then finally, sketch a residual plot. You can sketch a residual plot. Go under stat plots. It's kind of like a scatter plot. Actually, maybe before I sketch it, I should turn. So here's my least squared regression equation. I don't need that anymore, so I can turn that off. Highlight the equal sign and hit enter. Not a big deal if you left that on. It's just going to leave a line going through your residual plot. But anyways, if you go under stat plots and then under your first plot, and then you make a scatter plot just like we did before with your x values, but instead of your y values, what I want to do here is put in my residuals. So that's under list. So I hit second and stat, and then go down to residuals. So what I'm saying is make a scatter plot with my x values and the residuals. And if I zoom stat again, it'll give me this. So here's part 7 down here. Well, try that again. It's my residual plot. I have one way up here, and then I got a few down here, it looks like. Kind of something like this. And so I kind of have a pattern going on here. Your residuals are supposed to be completely random, but they're not. I kind of got this pattern going on. This exhibit shows patterned residuals. Patterned, I think that's spelled wrong. Residuals. So what that tells us is that nonlinear regression may be appropriate. In our class, we don't do nonlinear regression, so someone in a different class, maybe they could. But for us, all we do is recognize pattern residuals means that nonlinear regression may be appropriate, and that's the end. So that's the end of this problem.